All, myself Nagarajan, Assistant Professor in Department of BC at the Rohini College of Engineering and Technology. In this video, let us see the optical communication, third unit, optical sources and detector. Topic is here, intrinsic and extrinsic material, direct and indirect band gaps. Let us see the intrinsic and extrinsic material, optical sources. After completion of this video, the student will be able to understand the intrinsic semiconductor band gap, extrinsic semiconductor band gap. So let us see the intrinsic semiconductor. So the optical output from a source is measured in radians. Radians is defined as the optical power radiated in the solid angle per unit emitting surface area. Radiance is specified in watts per centimeter. Stadia. Radii is important in defining source to fiber coupling efficiency. Two types of light sources used in fiber optics are light emitting diode and laser diodes. LED is monochromatic incurrent sources, whereas laser diodes are monochromatic coherent sources. Characteristics of a light source for communication. To be useful in an optical link, the light source needed the following characteristics. It must be possible to operate the device continuously at a variety of temperature for It must be possible to modulate the light output over a wide range of modulating frequencies. For fiber links, the wavelength of an output should be coincide with the one of transmission windows for the fiber type used. To couple large amount of power into an optical fiber, the emitting area should be small. To reduce material dispersion in an optical fiber link, the output spectrum should be narrow. The power requirement for its operation must be low. The light source must be compatible with the modern solid state devices. The optical output power must be directly modulated by varying the input current to the device. Better linearity to prevent harmonics and intermodulation distortions. High coupling, high optical output power, high reliability, low weight and low cost, high radiance. Radiance is the ability of an optical source to emit optical power in a specified directions. Direct and indirect band gap materials. Materials in which the conduction band electron can recombine directly with a hole in the valence band is called direct band gap materials. Since electron hole recombination exists, emission of light is possible in direct band gap materials. There is no electron hole recombination, hence light emission is not possible in indirect band gap materials. So direct band gap material have minimum energy of conduction band and maximum energy of valence band have the same value of wave vector, but indirect band gap material have different value of wave vector. The energy of photon is in direct band gap materials and lifetime of charge carriers is very less. The indirect band gap material have longer lifetime of charge carriers. Direct band gap materials are used to fabricate rectifier diodes, transistor for amplifiers, switches and ICs. Examples of direct band gap materials are INP, gallium arsenic, and examples of indirect band gaps are silicon. Difference between the direct band gap semiconductor and indirect band gap semiconductor. So in a direct band gap semiconductor, that is a DBG, is the one which the maximum energy level of the valence band aligns with the minimum energy level of the conduction band. In the indirect band gap, which is the maximum energy level of the valence band and the minimum energy level of the conduction bands are misaligned with respect to the momentum. In a DBG semiconductor, a direct recombination takes place with the release of the energy equal to the energy difference between the recombining particles. In IBG semiconductor, due to the relative difference in the momentum, first the momentum is conserved by release of energy, and only after both the momenta align themselves, a recombination occurs accompanied with the release of energy. In the DBG, that is the probability of radiative recombination is high. In the IBG, the probability of radiative recombination is low. This a difference between the direct band gap and indirect band gap. Diagram. Review questions. Thank you, dear students. I hope that all of you understood about this video. Thank you.